Hi everyone, and welcome. Today I'm doing another video on inlays. This time it's a 3D model I've inlaid into this piece of MDF here. I'm going to take you through how I used Vectric Cut 3D to do the model here, and then how I used VCarve Pro, another Vectric product, to work out how to cut around this model to cut it out, and how to do the pocket for the inlay. So let's go and have a look at it. I've loaded a 1/4 inch down cutting spiral bit into the machine, and I've loaded the rough cutting file. I'm going to use the 1/4 inch bit to remove most of the unwanted material, leaving about 1 millimeter of material to be removed by the 3 millimeter ball cutter I'll be using later. I have zeroed the cutter to the tabletop and called it a nominal value of -18, which is what I told my CAD software this here was. You'll notice that when I came and set the cutter back to origin, it made a dip here in the center of the wood. Now that's not a problem here because my model is 9 millimeters thick. I want to leave 3 millimeters on the bottom for my inlay. That's a total of 12 millimeters. My wood is 18-ish millimeters thick, so that means that there's 6 millimeters of this wood that needs to disappear to start with before I even get down to the model. For this demonstration, I'm going to be using a free model I downloaded from 3dvectorart.com. Here it is here. I'm going to make a couple of little modifications to it. One is I would like it to be 80 millimeters wide, and I'd like it to be 9 millimeters high, but I don't want it to be any wider or longer, so I'm just going to unlock X and Y ratios and just change that to 9 millimeters. Apply that, and there we have it. It's now the size I would like it. That depth is just a personal preference on my behalf. Now I'm going to enter in my stock dimensions: 200 wide, 90 millimeters deep, and 18 millimeters in depth. I'm also going to use the center as my origin point, and I'm going to call it X0, Y0. We'll apply that. Let's now have a look at our material as it would be at the moment. We have our 18 millimeters of depth here, so we've got 9 millimeters of model, so basic mathematics tell us there must be 9 millimeters of uncut stock below it. I only want 3 millimeters of stock below for my inlay, so what I'm going to do here is I'm going to come down to depth of model below surface and change that to 6 millimeters, and I'll apply that. Here we have now 6 millimeters of material cut away, then 9 millimeters of model, giving us 15, and another 3 underneath, bringing us to a grand total of 18. We'll now move on to our roughing toolpath. I'll be using a 1/4 inch down cutting spiral bit, and each pass will be 1/8 of an inch. I'm going to be using a 5 millimeter clearance gap, 1 millimeter of machining allowance. That will be basically a minimum of 1 millimeter of material will be left above the model once this roughing toolpath is complete for the finishing toolpath to cut away. I'm also going to be using a strategy of Z level as opposed to 3D raster, and I'm going to be using raster along the x-axis. We'll calculate that, and we'll just have a wee look at that there. Next we're going to have a look at our finishing toolpath. For this I'm going to be using a 3 millimeter ball nose cutter. I've got a 5% step over, again a clearance gap of 5 millimeters, and I'll be cutting along the x-axis in a raster pattern. Calculate that, and there we have it. Now interestingly enough, you can see here the estimated time for the finishing toolpath is 27 minutes. When I did it, the actual time was 29 minutes. And looking at the roughing toolpath, it says 10 minutes, it took 11. So these estimates are pretty good. The next step is the cutout toolpath. Now I don't want to do my cutout toolpaths here in Cut 3D, I want to do it in VCarve Pro. So I'm going to ignore that and just move on to next. And now we can have a quick look at our roughing toolpath preview. So here we have it here. And what you'll notice is you're getting a little piece here that stands up. And when I run this finishing toolpath, you'll see that it's not part of the model. So when you're machining this bit, if this breaks off, and in my case it did, then you don't need to worry about it. It's not part of the model. The next step is saving the toolpath. So we have our post processor here. In this case I'm using Mac 3, so I've got the Mac 3 post processor, and I can save my roughing toolpath and my finishing toolpaths. Save them to my flash drive, take it to my machine and cut this model. So I'm just going to save this here as 3D Inlay. We'll just save that. Okay, now that's complete. I now need to do a second model. I'm going to come back to step 2, and I'm going to change my thickness to 9mm, which is the actual thickness of my model. I'm going to make my material thickness, I'm going to tell my material thickness it's the same thickness, and I'm also going to get rid of my depth below the model, below the surface for my model. And if we have a look now, you can see there the depth of my stock is showing the same as the depth of material, and I'll explain why that is shortly. So we do need to calculate toolpaths. We're going to use exactly the same settings as we had before. And there we have it. And I'm now going to save this as 3D Inlay cutout, because I'm going to be using this to generate my cutout toolpath in VCarve Pro. We start by creating a new file. I'm going to open up the original 3D Inlay file so you can see what the effect of not creating that second cutout file is. Here we have our 3D model, and we have a great big black square around it. With that, I cannot create a cutout toolpath at all. So we'll close that, won't save it, create a new file, and open the 3D Inlay cutout toolpath, the second file I made. Now you can see the difference. Here we have a nice model that we can easily create a vector toolpath from. We do this by selecting our model and come over here to fit vectors to bitmap. I'm going to set my corner fit to 100% and my noise filter to 1 pixel. And close. I can now select my model and delete it. I can also come over here to the toolpaths that we also imported and delete them. We don't want them. Here we have an outline of our 3D model. Normally when you buy a model from 3dvectorart.com, it comes with this particular vector, which you can use for cutting bits and pieces out. However, you may not buy your model from 3D Vector Art, in which case you've got to make your own. So this is the method I've come up with for creating it anyway. There is, however, a couple of problems with this particular vector, and it's true of all vectors you generally generate for inlays. Imagine I have my cutter and it's coming around here, cutting out this model, my 3D model. It'll have no problem going around that pointed part there. However, when I come to cut the pocket out, it will not be able to get into that corner. So the upshot is the two pieces will not match. They won't go together. Likewise, I have the same problem here. When I'm cutting the pocket, I can get this nice sharp corner. When I'm cutting out my model though, I cannot get into that corner because of my cutter radius. So I need to sort all these out. The new version of VCarve Pro version 7 has an inlay toolpath button, which you just push and it's all done for you by magic. On the other hand, I don't have that. I'm running 6.5, so I have to do it manually. I select the vector and select offset vectors. I enter in here a distance, which is my cutter radius, 3mm cutter I'll be using, so this is 1.5mm. I'm going to move the model inwards, so we just create this offset toolpath, and here we have it here. What I'll also do is I'll select the original toolpath and I'm going to move it to a new layer, layer 2, and I'm just going to make layer 2 orange so that we can see the difference between the new and the old. I now select the original vector, and again, I'm going to offset it by 1.5mm outward this time. I haven't selected my vector. There we go. And there we have it. Let's delete this vector here, the intermediate one, and have a closer look. Here we got it. We have our original toolpath here, and we have here a nice cutter radius which will allow the external cutting and the internal cutting to provide to match when we do our inlay. But the problem is we haven't fixed this area here. We've still got the same problem. Again, we select our newly created vector, and this time I'm going to offset it outwards by 1.5mm. And now I have to delete that intermediate vector, select my new vector and move it inwards, our 1.5mm. And now we can delete that intermediate one. Okay, so here's the finished result. You can see here I've taken care of this piece here and this piece here. All sorted. We can get rid of the original vector, and this is what we're going to use to generate our toolpaths. We can select this now, go over here to toolpaths. We first of all need to create a cutout. I'm going to use a 3mm cutter. I've got 3mm material left. I started off at 18. Advanced mathematics will tell us we've got a start depth of 14. There's 14mm of material not there, so we don't need to cut that, and we just need to cut down another 4mm. And it's probably a good idea to put a few tabs in, say 5mm in length, say 2mm, I'll make it 1mm deep. Actually, I'll make them about 10mm wide, 1mm deep, make sure it's well held. Calculate that. Oh, we better add those tabs in there. Add tabs. Edit tabs. And I'm just going to put in 8 tabs. Add tabs. And calculate. Okay. So we can preview that toolpath, and there we have it. It'll cut down and leave us some tabs there as well to hold it in place. You might want to edit where those tabs end up so they're easy to get at and sand. But I'm just doing this roughly to demonstrate the idea. We'll just reset that preview, close that, and now we want to select the same toolpath, but this time we want to make a pocket for it. I'm going to use again the same 3mm end mill, and I'm just going to pocket it down 3mm. Calculate that, and we can preview this toolpath as well. And there we have, this is the pocket for our inlay to go in. Because they're both generated using exactly the same toolpath, they should be a perfect match. We can now save these files and cut them out on the machine. Now there's one thing I'd like to mention. It is vitally important that when you cut the profile cut around your 3D model and the pocket cut into your material that you're going to inlay that 3D model into, set your machine to exact stop machining, not constant velocity. The reason behind that is that constant velocity machining tries to keep the machine up to the same speed, and it does that by calculating ahead and cutting corners. So it's going to make up its own toolpath for the profile one and do exactly the same for the pocket one. At the end of the day, the fit will be very close, but it won't be exact. So just for when you're doing that, set your machine to exact stop and you should get a much better fit than using constant velocity. Right, well now we've generated these toolpaths, let's see how we got on in the real world. So we're now ready for our first fitting. Now the most important thing here is do not remove this piece from the table until you've fitted this piece into it. If you've made this a fraction too small, then it's really easy to fix by running a new pocket profile, a new pocket, or just a wee profile around the inside here and just make it a fraction bigger. But if you remove this from the table, you no longer have that option. Your only option after that is either try and sand this bigger or sand this smaller. Now I've been around this here with some sandpaper, removed my holding tabs, and I've also beveled the back edge of this here so that it can start a little bit easier. Right, if you're going to do any cleanup to this, this would be the time to do it as well. So let's see if it fits. And there we go. It fits in. The pocket looks to be the correct depth. So I'm really happy with that. Well, it really is as simple as that. I hope you found this video useful, and we'll have a go at making your own 3D inlay at some stage. In the meantime, thanks for watching, and I'll catch up with you guys again later. Cheers!